So let's go ahead and we're going to roll into formulas. What we're doing with formulas is, in principle, actually in practice, essentially the same thing as solving a linear equation. We're doing our inverse operations. We're adding or subtracting to move things from one side of the equation to the other. We're multiplying or dividing to remove coefficients from one side of the equation to the other. The only difference is that we're, for the most part, not able to actually do any calculations. We're just showing it and moving it, okay? Because I'm dealing a lot of times with formulas or multiple variables, and so if I don't have like terms, I can't actually do the calculation. All I can do is show the calculation. A lot of times we use this when we apply formulas so that we can take a basic formula, rewrite it, highlighting whatever variable it is that we want, and then we can use it to evaluate. One of the most common examples is our distance formula, converting between Fahrenheit or Celsius or Kelvin temperatures, things like that. We use rewriting the formula in order to simplify the work for evaluating. Okay? So when I'm looking at this equation here, it wants me to solve for k, which means I want to get k by itself. My goal, or my answer, goal, is k equals something. K equals a bunch of stuff. And it's all those other numbers and letters. So I want k by itself, and then everything else on the other side of the equal sign. Okay? So think back yesterday, we're solving. Okay? What operations do I have in this equation? What two operations do I have in that equation? Multiplication and addition. Okay, so I have to undo both of those in order to get k by itself. I need to undo multiplication and addition. Which one am I going to undo first, the multiplication or the addition? The addition. I want to undo the addition first, just like we do when we're solving our linear equations. We want to undo addition or subtraction. So I need to undo that plus 3b by doing what? Subtract it. Minus 3b from both sides. Okay? Now, m and 3b are not like terms, so I can't actually do the subtraction. All I can do is show it. So m minus 3b. And then that cancels, leaving me with just 2k. So I undid my addition. Alright? Now, how do I undo my multiplication? Divide by 2. So I'm going to divide everything by 2. Okay? Now, two ways we can do it. I can do two big giant fraction bars. Okay? And then I get k equals m minus 3b over 2. That's one way. Okay? Divide the whole thing. Now, sometimes it's more useful to have it separated. Okay? So same process, m minus 3b. We're still dividing by 2, but instead of having one giant fraction bar, I'm going to have 2. Okay? Divide each term. When that is more relevant is if I have a coefficient that can simplify with what I'm dividing. So for example, okay, let me change this question slightly. If I had 2k equals 4m minus 3b, and I'm dividing by 2, it would be more prudent to do the separate division, because then I can simplify that fraction. Okay? So it's going to depend on the nature of the problem. That simplifies to k, that simplifies to 2m, and then that stays as 3b over 2, but it allows me to simplify part of it. Okay? So depending on the nature of the question, we'll determine which one you want to do. Alright? Can't really give you a hard and fast rule on it. It's just going to take some looking and see what part of this, if I write it as separate fractions, or can I leave it as one single fraction. Okay? Questions on that? Yes. Which part? The whole thing. From start to finish. The last like 5 minutes. Okay. Do you understand why I subtracted? if I had 3x plus 2 equals 17, what's the first thing I'm going to do to solve for x? If I had this right here, what's the first thing I would do to solve for x? I'm going to get rid of, I always undo my addition or subtraction first. I need to get this term alone before I divide. So I undo my addition, so I subtract both sides by 2. Okay, I did the same thing here, but it's with a variable as well. I want the k by itself, so I'm going to subtract 3b, so that 3b goes away from where the k is, but I can't actually do m minus 3b. So I just write m minus 3b, and I leave it like that. But it's the same step. Okay, solving a linear equation, solving for a specific variable. The steps are the same. It's just here I can do 17 minus 2. Here I can't, so I just leave it. And then same thing. Then the next step is divide. Get rid of the coefficient. I'm going to divide by the coefficient here. So I have 3x equals 15. Divide both sides by 3, so the coefficient cancels out. Same thing here. Divide both sides by 2, so the coefficient cancels out, leaving me with k by itself and then everything else on the other side. Okay? You're welcome. Alright? Next. Alright, so now this one's a little bit different because I have that grouping. Okay? I have that 1/2 on the outside. So, again, what two operations do I have here with my x? Okay, distributed is what operation? What other operation do I have?
Addition.
Addition. Okay, so I have multiplication as part of distributive property, and then I also have addition. All right, so this one's going to be a little bit different from the last one. Which one am I going to undo first? I'm going to undo the multiplication because I have this parentheses now. Remember, we're doing our order of operations backwards. Okay, my order of operation is groupings, exponents, multiply, divide, add, subtract. Groupings are done last. So since x plus 3 is in a grouping, I have to get rid of that 1/2 first before I get rid of the plus 3. Jordy, you got that thing?
Yes.
You sure? So undo this multiplication of 1/2. What do I do? Okay. So if I have, let me write this so I have a little bit more space. Okay. Opposite of multiplication is division. So I divide both sides by 1/2. Okay. But when I divide fractions, I don't actually do division of the fraction. I rewrite it as multiplication of the reciprocal. So instead of doing divide by 1/2, I can just multiply both sides by 2. What's 2 times 1/2? 1. That cancels. Okay? So I'm left with 2y equals x plus 3. Those canceled out. I undid that multiplication of 1/2 by multiplying by 2, multiplying by the reciprocal. Now, last step should be subtract 3. Okay, so subtract 3, 2y equals, 2y minus 3 equals x. Again, they're not like terms, so I can't actually subtract them, so we just show it, we just write it. Questions, comments, concerns? All right. Good. Now, We have surface area of a prism. I'm solving for W. What's the big difference between this one and the last two examples in what we're solving for? Right, but what's the big difference between when I solve for Y or when I solve for K? I've got two of them. W's in there twice. I only need it once. Okay, I can only have it once. Not quite. First thing, let's get that moved away, because that doesn't have a W in it. So I don't need to do anything special with it. So how do I move 2LH from one side to the other? Subtract it. A minus 2LH equals 2. It's a wonderful sound, right? All right. Now, I still have those two W's. All right. I need to turn them into one W. So what we're going to do, everyone's favorite F word, factor. Factor out the W. That takes 2 and turns it into 1. Okay? Factoring is just the opposite of distributed property. So think, if I did W times what, would I get 2HW? 2H. And then same with 2L. So I undid the distributed property, which is what factoring is. I factored out that common factor of W, so instead of having 2, now I have 1. Now, I need to move this entire grouping, divide, by the whole grouping. Divide by the entire grouping. W is being multiplied by that parentheses. So divide by that parentheses. That eliminates. W equals that.
Is that a homework? Like something like this?
Also, thank you for reminding me, see how those are all uppercase? When you do your homework, you have to match the casing as well. If the letter's uppercase, it needs to say uppercase in your answer. If it's lowercase, because different variables have different things, and the meanings will vary based on the formula. Okay? Some formulas may have the same letter in it, but one's uppercase, one's lowercase, and it means different things. Okay? So you need to make sure that you're matching the casing, uppercase for uppercase, lower for lower. Questions on that? Flying through. We're almost done. Now we're going to use the formulas. Okay? So I'm going to give you formulas when you need them. Okay, so you don't write them. But you do have to know kind of what each one represents. Most of the time, formulas are pretty self-explanatory as towards the meaning of the variables. Or they're going to tell you, hey, this variable represents this thing. Okay? So I'm going to use, since I'm talking about distance, I'm going to use the distance formula, which is distance equals rate multiplied by time. Equals rate multiplied by time. Okay, DRT. So we have a distance of 500 miles and a rate of 25 miles per hour. Find the time. So what am I solving for? Time. So let's isolate time first before I solve. How do I get T by itself? Divide by R. Okay? Get T by itself. We're going to divide by R. I promise that's an R, not a V. There we go. Okay? So time equals distance divided by rate. Okay? Same formula, but we're highlighting a specific part. Whatever it is that I need for this problem. I need time, so I'm going to highlight time, and I'm going to isolate it, and everything else on the other side. Okay? What's my distance? What's my rate? Solve. 20 hours. Thank you. I had to like double check my rate. 20 hours. I'm not a physics teacher, so I don't care that much about units. You need to note them and be aware of them because sometimes they'll give you units in different. They may give you hours and they want the answer in minutes. So be aware of your units, but if you don't write them, I don't care. Math is so much purer. Alright. So just kind of refresher on percents. Okay, percent means out of a 100, out of 100, percent. Cent is 100. Okay, so out of 100. Being able to convert back and forth between fractions, decimals, and percents. We don't do math with actual percents, only with decimals and fractions. So when you're given a percent, you must rewrite it as a fraction or a decimal notation. Okay, I can't multiply by 5%. I can multiply by 500ths or 0.05, but not by 5%. Okay? When you're looking at trying to find a percent, it's a part over a whole. Okay? How much do I have out of what the total is or what the total could be? Okay? And that will give you the fraction if you simplify it or do the division to get the decimal for the percent. The partial will always be smaller than the whole amount. Okay? So just, if you think about it for 5 seconds, it should make sense. The partial will always be smaller than the whole. All right? Now, using percent, a lot of times we're either doing multiplication or division. Okay? Commission, sales tax, interest, simple interest, compound interest, those all use percents. Okay? Commission's pretty straightforward. Salesman earns a commission of 8% on every car he sells. He sells one that's $12,000. How do I find 8% of $12,000? Yeah, we're going to multiply. 0.08. 0.08 times 12,000. So, how much money did he make? $960. Not bad for a few hours work. Pretty straightforward. Uno más. Alright, reading the chart, figuring out what percent we need to deal with. In 2005, people in the United States spent an estimated $35.9 billion on their pets. I'm pretty sure half of that is probably for horse care. How much was spent on pet supplies and medicine? Round your answer to the nearest tenth of $1 billion. So what percentage value do I need if I'm looking at supplies and medicine? 24.5%. Okay, I want that section. 24.5%. 24.5% of how much? 35.9 billion. Now, pro tip. I've seen it half a dozen times every year. Someone will take 35.9 billion and write it out as 35900000000, and then try and do the math and like, this doesn't fit in my calculator. You don't need to do that. Think of billions as a unit. 35.9 billion is a unit. You can leave it as 35.9. And when you do your multiplication, your answer will be in billions. So you can leave it. And they want you to round to the nearest tenth of a billion, which is how many decimal points? Is how many decimals? So your answer is going to look very similar to that. Okay? 35.9 billion is already in tenths of a billion. Okay? So we just need to do our multiplication. What's 24.5% in decimal notation? 0.245. Okay, move your decimal 2 places to the right. Okay, so that is our decimal notation times 35.9. So how many $1 billion is spent on supplies and medicine? So it gives you 8.76, right? 8.79. So then you round up to $8.8 billion. 8.79 rounds to $8.8 billion. Questions, comments, concerns, queries, or
What is that?
$8.8 billion.
Oh.
Cool. All right.